Hello, this is Frank Allen at Davis High School chemistry class. This is a lecture from Unit 4 covering Lewis structures. And the purpose or objective of this lesson is you have to learn how to draw a Lewis structure. So we're going to get started here. Just a couple of things. Lewis structure, it's called Lewis structure because some guy named Lewis invented this method of drawing the structures, and the structures of the diagrams show bonding patterns and where valence electrons are in molecules. It can be an elemental molecule or it can be a compound molecule, but it shows where the bonding is, how many bonds there are, and where all the valence electrons are. And these things affect various properties about the molecule, about the compound, such as melting point, boiling point. Will it dissolve in water? Will it not dissolve in water? And so forth. Now the vocabulary word valence electron, we've had that before in the past, and these are electrons in the last level of an atom's electron pattern. So if we're looking at carbon, for instance, carbon has 6 electrons, so we could, if we wanted to know the valence electrons, we'd have to write out the electron pattern. And we'd see that there are 4 electrons in the last level. Now that seems a bit tedious and it's time consuming to have to write out the electron pattern all the time. Fortunately, there is an easier way to determine the number of valence electrons. You simply look at the group number. Carbon is in group 4, and so it has 4 valence electrons. The group number corresponds, it just so happens, to the number of valence electrons. And so when we draw Lewis structures, we're trying to show where these valence electrons are, how many bonds there are between the atoms in the molecule, and that changes some properties. So Lewis structures, atoms are going to contribute their valence electrons to a molecule. Atoms are going to react and they're going to bond together. The question is, why are they going to react? Why are they going to bond together? It's because they all want, for now, they want 8 electrons around them, except for hydrogen. Hydrogen only wants 2. So the magic number, octet, 8. Atoms are going to create bonds and create molecules and compounds because they somehow want to get 8 electrons around them. And they will share their electrons to get those 8. Now, when drawing Lewis structures, the rules are fairly simple and straightforward. The first rule is determine the number of valence electrons that the structure is supposed to have. And to arrive at the correct Lewis structure, give everybody 8 electrons, except for hydrogen, just give it 2. And then you're going to create more sharing of electrons to reduce the number of valence electrons down to the correct number. So just taking a look at some examples, if we were drawing the Lewis structure for carbon monoxide, 1 carbon atom and 1 oxygen atom. Now it looks like this. Now, how do we arrive at this? This tells us that there's a triple bond between the 2 atoms, and you've got this pair of electrons. These lines are 2 electrons. You've done something like this in IPC where you use dots. We're just going to use lines. If you want to use dots, you can. These lines represent 2 electrons, so they are sharing these 6 electrons. That one has 8 around it. That one has 8 around it. Carbon is in group 4. Oxygen's in group 6. So we're supposed to have 10 valence electrons in our structure, and we do. 2, 4, 6, 8, 10. Now how did we arrive at this? Well, the rules are simple. Determine the number of valence electrons, 10. You're going to go ahead and connect the 2 atoms, and you're going to give everybody an octet. So essentially you're drawing a line on each side. We're not going to draw a line here because we've already got this bond right here of 2 electrons. Now we're going to count. Each time we perform a step, we're going to count 2, 4, 6, 8, 10, 12, 14. We're only supposed to be showing 10, even though they both have 8 around them. So what needs to happen is we need to create more bonds between them. Now every time you create a bond between 2 atoms, you have to erase a pair of electrons from each atom the bond connects. And then you're going to count again. 2, 4, 6, 8, 10, 12. We've still got too many electrons, so apparently we need to share more. Now you don't erase anything until you create that extra bond, but every time you create an extra bond between two atoms, you erase a pair of electrons from each atom. 2, 4, 6, 8, 10. That atom has 8 electrons around it. That atom has 8 electrons around it, and we erase these. And we have 2, 4, 6, 8, 10 valence electrons. So this is the correct structure. Let's try another one. Carbon dioxide. There's one carbon, there's 2 oxygens. The one carbon gives us 4. Each oxygen has 6, but there's 2 of them. So we're going to have to show a total of 16 valence electrons when we are finished, not when we're starting out. So we're going to put carbon in the middle because it's the one atom. And if you're not sure about what goes in the middle, I'll always point that out to you. And then we're going to give everybody 8 because that's the magic number. Now notice I only added 4 electrons here because carbon already has 4 electrons around it. So that oxygen has 8, that carbon has 8, that oxygen has 8. How many electrons are we showing? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We're showing 20 electrons, which is too many. So we're going to create an additional bond. It doesn't matter if you start here or here. But each time you do that, you have to erase a pair of electrons from each atom the bond connects. We didn't draw a bond from this atom to this atom, so we're not erasing anything here. We're going to count 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 2 electrons too many. So we have to create another bond. Now you can put a triple bond here or you could put a double bond here. We like to keep things symmetrical and simple. So it doesn't matter if you erase the top one or the side one or what have you from these atoms. That doesn't change anything. 2, 4, 6, 8, 10, 12, 14, 16. 16 valence electrons. That has 8. That has 8. That has 8. If I didn't erase this pair of electrons when I created the extra bond, I'd have 2, 4, 6, 8, 10. And it only wants 8, so I erase these. So this is the correct Lewis structure for this. This has been part 1 of this lecture. I'm going to upload another video that will be part 2 of this lecture. See you then.